Hopefully you have read chapter 5, the whole thing by now, and this is going to be over chapter 5, section 6 and section 7. This is probably the most difficult calculations for the chapter, so you want to be sure after the video that you go and practice a lot. Alright, so if you've gone through all the videos and done your homework to this point, now we are ready to use chemical equations. Okay, we've learned about them, now we're going to use them to calculate amounts of substances involved in the chemical reaction. So what we can do, just like when you were converting from feet, inches, centimeters, whatever it may have been, we can now use one known value of a particular compound in the reaction and find an unknown quantity of a different compound. So this is really nice. We can convert from one unit of one compound to a unit of a totally different compound in the equation. Okay, so we use the sequence grams to moles to grams. So you'll see this here later. But first we want to look at mole-to-mole relationships. Okay, so here's our equation. Just ignore the examples. I've just pulled examples from previous places. Okay, so if we look at this reaction, we have 1 mole, okay, understood 1 here in front of our iron 3 oxide. We have 3 moles of CO, okay, this number here, and this is just heat, so reactants, products, to 2 moles of iron and 3 of CO2. So this is important. This is the relationship between moles. So you have 3 moles CO, 2 moles iron. Okay, so what we're going to do, it tells us in our equation that we have 3.5, excuse me, I'm trying to get my pen here. Okay, we have 3.5 moles of our iron 3 oxide, which is right here. So you guys know how to name that. Okay, and we know that we have to have our units to cancel on the bottom. So just like what we've been doing previously. Okay, so we're asked for how many moles of CO. So this is what's different. We have a different compound. We're converting from moles of iron 3 oxide to moles of CO. So we could actually do this for any of the compounds in the equation, but we're asked for CO. So when we stop our equation or our calculation, we have to have moles of CO on top of our equation or our calculation in the numerator, not canceled out. Okay? So what we do in this step, this is a mole to mole relationship. So if we look at, let's just do relationships for any of these compounds here. We have 1 mole Fe2O3 for every 3 moles of CO. Okay, we have, let's do another one. Let's say we have 3 moles CO for every 2 moles iron. We have 2 moles iron for every 3 moles CO2. Okay, so all of these numbers, we could go on and on with ratios, okay, but we're coming up with a mole-to-mole relationship or ratio. Okay, and see we've got all of these that we can plug in. So what we're going to do, if we're asked for moles of a compound, and we're given moles, it's just one step. But our key step is to look at our balanced equation and plug in the numbers, our coefficients, for the compounds that we're looking at, and then we'll get moles of what our desired outcome. Okay, so we've got 1 mole Fe2O3, and we have 3 moles of CO. Okay, this is the only time and the only step that we're going to have, you can have more than 1 mole. So far, Avogadro's number was based upon 1 mole. When you went from grams to moles or moles to grams, everything was based upon 1 mole. Okay, here we have a 1 to 3. Okay, you could have a 1-to-1 ratio, but you can have numbers higher than 1 here from your equation. So So 3 came from here. That's what we're looking for. And our 1 came from here. Okay, so all you have to do, your moles here will cancel. So if you multiply 3.5 times 3, you get 10.5 moles of CO. Okay, so if we were to check our significant digits, we only start with 2. So what we would have to do is convert this to 11 moles. Okay. Okay, this one is the big one here. So these you will want to practice a lot. These come from section 5-7. Okay, and what we're going to be doing is going from, now that we know how to look at our reaction and see our mole-to-mole ratios, okay, we're going to use this, but we're going to do something. We're going to go from grams to moles to grams. Okay, so each time you see one of these arrows, this means that's a separate step. Okay, so this is going to be 3 steps. Okay, the key step, which is the one that we just talked about, is this mole-to-mole step. This is where you use your ratio from the equation. Okay. Here we are given that we have a mass of 146 grams Fe2O3. Okay. Okay, so we write out what we're given, always. Okay, so now we've got to go from grams of Fe2O3, so this, to grams of CO. Okay, so we're going to have to go through a 3-step process. We've got to go from grams to moles. Okay, and this is back from, I guess, section 5-2 or so, where we just went from grams to moles. It's the same step, it's just the first step, then we go to another one, then we go to another one. Okay, these steps, we're going from grams to moles, moles to grams. We've already learned these steps. We're just now putting them together into a 3-step sequence. Okay, so the first thing that we have to do is add up the molar mass of Fe2O3. And we know that this is always going to be based out of 1 mole because the periodic table is based out of 1 mole. Okay, so if we get your periodic table out, okay, and we look for iron, okay, it's 55.85, and you've got 2 of those, so times 2. And you've got oxygen times 3. Okay, so we get 159.7 as our molar mass, grams per mole. Okay. Now we are going to, so our grams cancel, okay, but we're left with moles of iron oxide on top. Well, that's not what we're trying to find, so we can't stop here. We've got to keep going. Okay, so we've done this step, grams to moles of 1 compound. Okay, so if we keep going, we can put moles. Go ahead. This helps you keep your units and everything in order. As long as you're putting, you have your units here have to cancel with the units down here. So diagonal, they have to cancel. So you have up top, you've got to have the same units on the bottom. Okay, this is our key step. This is where we use the reaction equation to come up with our mole-to-mole ratio. Okay, so we have 1 mole Fe2O3, and we're looking for grams of CO, but right now we got to go to moles because that's our only relationship that we've got. So we've got 3 moles of CO. Okay, so if we cancel here, so we're left with moles of CO on top. Okay, and don't let this be too complicated. The only step we're really adding in here is the mole to moles. Okay, now we're just going from moles of CO to grams, just like we did earlier in the chapter. So we know that we always base our atomic or molar mass on 1 mole. So every step, you can only have 1 mole except for this step here, which is your mole-to-mole ratio, where you're using the numbers in the equation. Okay, so if we add up the molar mass of CO, we get 12.01 for carbon plus 16 for oxygen. So it's 28.01 grams of CO. Okay, so see here why it's important that you not only put grams or moles of a compound, that you write the compound, okay, because we went from grams of one compound to grams of another. Okay, so moles cancel there. Okay, now you multiply everything on the top and divide it by everything multiplied on the bottom. So if we have 146 times 3 times 28.01, and we divide this by 159.7, we get 76.8 grams of CO. So far, we've just been looking at CO and iron 3 oxide. Okay, but we've got other relationships here. So we can use any of these relationships as long as we're given one quantity. We can use any of these relationships to find out how much of another compound is produced. Okay, so this time we're given 8.6 grams of carbon dioxide was produced. So someone did this reaction and they found that 8.65 grams of CO2 was produced. But then they want to know, well, how much iron oxide did they have to, iron 3 oxide to be exact, did they have to use to produce this CO2? So how much of the iron 3 oxide had to be used? Okay, so we write out what we know always and our units. Okay, we're going from grams to moles to grams again. Okay. So if we add up the molar mass of CO2, so 12.01 for carbon plus 16 plus 16, 2 oxygens, we get 44.01. It's 12.01 technically for carbon. Okay. And we know that it's always based out of 1 mole when we use the periodic table. So our grams cancel. So all we did in this first step was go from grams to moles of a known. So if we even say known. Okay. This is our key step. This is where we do our mole to mole ratio. Okay. So if we look at our equation, we've got 3 moles CO2. This is the only time that we have more than one that can be plugged into our calculation. And we're looking for mass of iron 3 oxide. But first we have to go to moles, so this is what we're looking for. And we have 1 mole of C2O3. Not just 1 mole, we have 1 mole of iron 3 oxide. Erase this. Okay. Now we have to have moles of iron 3 oxide on the bottom because these have to cancel. And we know to go from moles to grams, all we have to do is multiply times the molar mass. And I believe we found earlier on the previous slide 159.7 grams per mole. I'll go check it in just a second, make sure I was right. Okay, I think I'm right, but I'll come back and change it if not. Okay, so now moles and moles cancel, so we have to use 1 mole because the periodic table is based on 1 mole. So we just added up and got 159.7 grams of iron oxide. Okay, so what's left uncanceled and on top is what we're looking for, the mass in grams of iron 3 oxide. So if we do the math, so if we take 8.65 times 159.7 and divide this by 44.01 times 3, should get about 10.5 grams of iron 3 oxide. Okay, so check your answers here. I'm double checking, be sure everything is right. Okay. This concludes the video on our chemical reaction equations, and be sure you also notice, before I end this, that we have balanced equations. Okay, so everything has to be balanced, like we learned in the last video. Okay, so we go from grams to moles to grams. The key step here that's different is our mole-to-mole ratio that we get from our reaction equation. Thank you, and good luck to you all.